All right, so Angie Hodge, who's one of the co-organizers of the whole conference, said, all right, Stan, you have to give a talk and you have to also run the session. So this is the reason why I'm here today. So thank you, Angie. She's not here, but thank you, Angie, for telling me to do this. And so I'm giving the first talk for this session. So this is using IBL in courses for future elementary teachers, doing math, video lesson study, and addressing beliefs. So I'm going to start with a quote that I heard from Bill Jacob. He may not be the originator of this, but he talks about it this way, which is math for elementary teaching is the most important course you will ever teach. And we've had this discussion several times, and he tells it when he runs workshops. And I believe that, of course, right? The elementary school teachers are such an important, probably the most important level of our educational system. So what I want to do is start off with some quotes from my students at Cal Poly, who are elementary ed majors. We call them liberal studies majors in California by law, but they are elementary ed majors. Okay. All right, so here's Jen. And she said, the first time I remember doing anything with numbers was in kindergarten. I wrote all the numbers from 1 to over 500. I remember feeling very proud of myself. And that was the last time I felt brilliant at math. I do well in the classes, but I don't feel as though I understand it. So this is where they start at the beginning of the year. And I'm going to share a few more. In chapter 1 of Thinking Mathematically, the author states, probably the most important lesson to be learned is that being stuck is an honorable state and essential part of improving thinking. I wish I had heard that in grade school. I felt being stuck meant you are stupid or math just isn't the subject I am great at. Okay, so here's Tara. Since elementary school, I have always done pretty well in my math courses, but I never seemed to enjoy the subject quite as much as other subjects. It was never as appealing or enjoyable to me because it seemed to be more rote-based and did not capture my attention because it did not allow for creativity. There was always one right answer. Right? And these kind of go on, and I'll go to the shorter ones. I always dread math classes because of the many negative experiences I have had with them. Math has become one of my personal enemies. Right? This is the antagonist equals math is a common thing that comes up, actually. My experience in math has been very negative, long, and discouraging. And the last one, saying I do not like math is an understatement. So these things go on. And so usually between a half and 3/4 of the students have these kinds of attitudes about mathematics. And these are future elementary school teachers. Right? And then Cal Poly freshmen. I want to share with you that these are very good students. So this is sort of the brightest picture that we have in California for this segment, right? For these kinds of majors. All right, if you look in the science and mathematics, so our elementary ed majors are in the College of Science and Mathematics. And their average GPA from high school is 4.04. Right? Their ACT average is 30. Right? And their SAT 1 average is, what is that? 1322. Right? These are good students, right? If you want to put that in quotes. So in California, we would say this is about as good as it gets for this population. And it only gets tougher from there. So what now? Right? It's a question. So these are your students. This is how they feel on day one about mathematics. So that's the challenge that's facing us. All right. So what I've done by talking to people and reading and thinking is I thought, well, I need to characterize the situation to some degree at least to capture what's going on. Or at least list some of the challenges that I can start to chip away at. So I came up with this little diagram when thinking about this talk. And it's to highlight some of the challenges that we face in teaching this course. So, and there are more than these, but I just listed these for now. So one is that math is a rote skill-based subject, right? Just computation. So they think you know math if you can do 5 + 4 = 9. And that might just be memorized. All right, so little to no experience with active learning in mathematics. It's common. Most students at this point have not experienced very many courses where they've been actively engaged as a regular habit. Content knowledge deficiencies exist. Once you get to fractions, right, you find out what they do and don't know about mathematics. Of course, as I've mentioned, the negative attitudes and beliefs about mathematics. And what we've only done is talked about how they feel about it, but they also believe in things like all math problems can be done in 5 minutes or less. Otherwise, there's something wrong with you or the problem, right? If that's a belief that you hold, you're going to engage in mathematics in a way that's very different than a mathematician. There's math knowledge for teaching. That's another area where knowing about mathematics that informs how you might teach it, right? So this specialized area of math knowledge, separate from math knowledge for building bridges. Okay, so there's an area called math knowledge for teaching. And then children's mathematical development. Even if you know why invert and multiply works, so what is the development in school children? That needs to be also in there. And I'm sure I've missed things that you might think of, and I'll just put them in the other stuff category that we won't go into. One of these great books, Donald Finkel wrote, Teaching with Your Mouth Shut. Great book. I finally got my hands on it. And he has this chapter on let the books do the talking. And I found that wonderful idea. And we're doing that in the IBL math community through our problems. We let the problems do the talking, right? And the sequence of the problems. So what I thought would be nice for this Math for Elementary series is to let the books do the talking and articles, but also the problems and videos and those things combine. So generalizing the book to articles, including articles, problems, which are math problems, and videos, that they will do the talking. And then the class would be about discussing these items, and then they can come to their own conclusions. So when faced with students who don't like math, yet they're going to be your child's math teacher, in my case, literally, I have a 6-year-old, and some of my former students are now student teaching in his school. Like, this is literally a personally important endeavor for me. So it wasn't enough, I felt, to just tweak the course and say, all right, let's do some group work now. Let's see if I can chip away at this problem. I felt like I had to do something more. So my goal was a little broader. And so I felt like I need to transform this experience for the students. It had to be more than just, I'm going to make some tweaks. And this took a long time. This took many years. So in this short talk, I won't be able to describe all of the development. But what I came up with is this structure here that I'm presenting. First and foremost, there's an IBL math curriculum. So every day it's about solving problems, engaging the students, they're doing math, explaining why things work. In addition to that, they also have reading assignments. So they're required to read articles and books about math learning and also about mathematics as an activity that they do outside as part of homework. All right, and this is a way or an opportunity for us to hit some of the attitudes and beliefs. I've also included video lesson studies. So this is from Bill Jacob. I went to visit him down at UC Santa Barbara, and I was able to learn about how to do that, how to implement these things in my classes. And then I modernized the assessment. If they're doing different things, I should measure differently than just giving an exam. I need to capture some of this other stuff that's going on. All right, so for this next part, I'm going to go pretty quickly, so I apologize in advance that it's going to be some highlights of what these things are like. So the IBL math, they're doing these activities, they're solving problems, they're working in base 5 to learn about place value and about grouping and unitizing and so on. They're proving the Pythagorean theorem, right, on their own with some guidance. The reading and reflective writing. So there are a series of books that are listed up here, which, so what's math got to do with it is about math education in the United States and how that works. And that gets them into their own learning experiences. And the reflective writing is a way for them to connect what they're reading to their own experiences. And there you start to chip away at their attitudes and beliefs. So you can give them prompts. How do you feel about math? What do you see in the reading that's related to your own experiences? Things like that. The next book, What's the Point of School? That should be available in the room upstairs. That's a great book, just giving you an overview of the educational system from a British perspective, which is similar to ours. Thinking Mathematically is a book like Polya's book about problem solving. So it's about how to be a better problem solver. And then the book Young Mathematicians at Work by Falsno, Dolk, and Jake. It's actually a series. That's about the development of children's mathematical thinking. And that's where you get the math knowledge for teaching. So you can have these as assignments throughout the year for them to read bits and pieces. All right. I want to switch over to the video component. What we do, and I don't have time to share this video. I have a 3-minute clip. Is essentially we show video of an IBL elementary school classroom. So the teacher presents, I'll just switch over to the pictures. The teacher presents a problem. They work on them in groups. We've seen this before, right? Then the students present their findings, and the class tries to make sense of what's going on. It's inquiry-based learning in 3rd grade or 2nd grade or 4th grade. And then they start to say, hey, what we're doing in class is parallel to that. And we're reading about it outside of class and reading about research that supports this. So they get to see what it looks like. If you would like to get these videos, they're available at heinemann.com. So they have a wealth of professional development materials for many different subjects. And they have K through 8 math units as well as videos for professional development. And those videos for professional development are the ones that I select for my classes. And you can go in there and find them yourself. All right, I'm going to quickly just talk about assessment. And basically, instead of just doing homework and tests, I've also added a portfolio and a presentation component. And in some of the courses, a final project in lieu of a final exam. And their final project is to be more focused toward the teaching practice. So they do some mathematical project related to teaching, which is more practical for their profession. And so I'm not going to go into the details. I'm happy to talk to you about these things. I'm going to end with a student response. This is, and they write these in their portfolios as part of their one of their final reflections. So I'll read this to you. As we went further into the course, we were able to connect ideas developed throughout the quarter to one central theme by revisiting previous problems and expanding on them. I thought it was interesting to see how we could build, expand, and connect the ideas upon one another, and even relate it to areas in calculus with problems that younger students would be working on. And it continues. The main importance of these types of problems is that students can learn to reason and problem solve, which will be extremely important for their futures. I wish I had been exposed to more of these types of problems in my elementary school education. However, this allows me to make certain that whatever classroom I am in, there is no doubt in my mind that I will be sure to implement the same methodologies explored within the math series. All right, so you start to see some of the students change in a direction that we want to see them. So I'll stop there, so thank you very much.
How large is your class?
Yeah, the classes are capped at 25, but we often go up to about 30 for enrollment reasons. Yeah. Or for homework? Oh, portfolio, yeah. So usually, the portfolio, the way it works is I ask them to select problems from the term, from either homework or in class. And we've already discussed the solutions at some point in the past. And what they do is they rewrite them and they expand the solutions, and they also connect, like, why is this problem important mathematically and also as a future teacher. So they have a correct solution in hand already. So, but then they go further from there. Yeah.
So at Auburn University, there's a math for elementary ed, but there's also like a separate, so there's a 3-course sequence, but there's also like math pedagogy for elementary ed. And I was wondering if you have a similar setup in your school, or are you trying to do kind of both?
It's the
seems
same.
like you're, okay.
Yeah, it's the same. So I'm in the math department, so I teach what they call content courses. And then when they go to the credential program, they take an elementary math methods course.
But it seems like you also emphasize the whole being aware of teaching math to children in your course.
Right. That's right. Right. So it's not a pure math course in the sense that we're only concerned about the mathematics. We connect it to the children's thinking, but we look at it through the math lens, right? What is the math here? And then in the credential program, they go into would you execute that, right? So I think that's a natural switch off point.
Do you have a sense of what the weighting of the course, how much is, because it seems like they're doing a lot of readings on, being aware of teaching.
Right.
How they teach. So what proportion, I guess, of the courses is that?
Okay, so that's all just done outside of class through the reflective writing and reading. And then the every day in class, except for maybe a few minutes we might talk about our reading, it's just doing the math activities. Yeah, so that's all pushed to homework. Good use of homework. Yes, Tom. Okay, over here.
Is there any chance for these teachers to become aware of the way that mathematics supports new technologies like cell phones, internet searches, and so on, even if it's not a subject matter either of elementary school or even high school?
Oh, just sort of like expanding their cultural knowledge?
Because,
Yeah.
when you ask people what math is good for, they don't realize that their cell phone is not merely a gift from engineering or physicists, it's a gift from error correcting codes, data compression, and these ideas in many ways are no harder than factoring polynomials. In some ways they're easier, it's just not part of the curriculum.
Right. I haven't gone in that direction, but I think that would be a great area to add into the reading or something, that they could watch a video or read something about it. I haven't done that, but thanks, that's a great idea.
So, what do your colleagues and the other people who are teaching this course think of this approach? Are they trying to follow in your footsteps, or are you just letting you do what you want?
Oh, I see. Yes, this is a good question about your department environment. So I'm in a department which in the fall we'll have 6 math education specialists in the math department. We're a big department. We have 35. We all are basically on the same page. And what we do is we vary to the level of IBL-ishness or IBL-ness. So I'm on the very IBL side, but there is no one who teaches the course who doesn't do active learning that engages students.
So is everybody using the videos, for example?
Most of us are using the videos, I would say, and then more and more are using it. I would say 4 out of 6 are using the videos.
We're 2 out of 2.
Okay.
2 out of 4, but no, 2 out of 4, not 2 out of 2.
Okay.
How did you get 4 out of 6 to use the video?
Oh, I don't have a good answer to that. I just act excited about these, and I share them, and we use them, and I think they just latched on. So it's not me. I didn't do anything. They said, "Oh, that's a good idea. I should use it." But you're right. I think there's a good question here. How do we get more people to do this? And my feeling is that we need to actually have professional development around this, because it's one thing to know that they exist. This is another to like how would you embed that into your class tomorrow, right? How do you run that? So yeah. So anyways, Tom, we should write a grant proposal or something, or okay, I'm gonna sign you up. Yeah, I've written it down. Okay. For some projects, it's like create a sequence of problems, but without the lesson planning component, so that the focus is on the mathematics. Like how would you correctly, what is a correct, but not the only correct way to sequence problems for, say, developing the notion of unitizing, so bunching into tens.
You're having them write their own IDL.
That's right. That's one of the types of projects, yes. And that's hard for them, by the way. It's so hard to write problems. So are we out of time for this? I think we're out of time. So it's 2:20. So thank you very much again. And our next speaker is Brian Katz. 5 minutes.